It is such an honor to be with you here today after my own graduation from Boston University over 20 years ago. And I spent the past 24 hours wandering around the city and checking out how amazing the campus is and how beautiful the city is that you're living in. I want to start off with some words of wisdom, more than 20 years since my own graduation from our university. And I want to say that I think you have done what very few have, which is to earn an engineering degree, which in my opinion is a degree that uniquely trains people to think, to invent, to create, and directly impact the world around them, and ultimately to make the world a better place. And for that, you should be so proud. And I want to start with my favorite quote from A Tale of Two Cities by Charles Dickens. It was written as an allegory in turbulent times, political unrest, and focused on the social inequity in the French Revolutionary period. And I think it argues, or I would argue that it resonates with the present day. The prologue begins like this: "It was the best of times, it was the worst of times. It was the age of wisdom, it was the age of foolishness. It was the epoch of belief, it was the epoch of incredulity. It was the season of light, it was the season of darkness, but it was the spring of hope." And we're in the spring right now, and I am hopeful about the future. And although this quote was referring to societal dichotomy, it's a relevant message to the professional world that you're about to enter. Whether it's a climate in peril versus the alternative view, in life, as in engineering, you are asked and challenged to solve problems that span belief systems, oceans, continents, our solar system, and even the fabric of space-time. So you always have to think about the big picture. You always have to think about the fundamental physics, the interfaces, the people involved, and most importantly, the impact of your choices as an engineer on society and their impact on the planet. And ironically, what I just went through is the definition of the systems engineering mindset, a logical view and decomposition of the problem and solution space that can be applied to just about anything in life. And this is why my father, who also was a PhD mechanical engineer turned entrepreneur, always said that a degree in engineering trains you for anything. Clearly, I listened, and I believe a similar ethos brought us together here today. Now, taking a step back, I want to share 5 actionable and tangible messages with you today that I've learned during my career journey to date since BU. And I'll present each career example with an overlap, in some case, with science fiction, which is a literary genre which I love because it allows for us to look at history and future to shape our imaginations. But the 5 topics I want to go through is first is knowledge, which is your foundation, rooted in the training that you've received here at BU and will continue to absorb during the course of your career. The second is humility, which is the recognition that in the vastness of the universe, we actually know very little, but we can strive to be and learn more. The next one is purpose, that we must create, we must engineer for a reason. The next one is resilience, that we can learn from our mistakes and failures and become stronger from them. And the 5th is compassion, to always help others in the world around us in our pursuit of innovation. But starting off with knowledge, knowledge is what makes the discipline of engineering so unique, and it's best exemplified by a quote from von Karman, who was an expert in the field of hypersonic aerodynamics. He said, "Scientists discover the world that exists. Engineers create the world that never was." So what does this mean? Scientists observe and understand the existing world, while engineers design and build the future. It's our knowledge, our training as engineers that enables us to do this. It's not guess and check. It's not measure and remeasure. It's an innate understanding of the physics, an application of that understanding to create something entirely new that functions, that we, the engineer, design it to. So an example from my career is my PhD research was in electric propulsion for spacecraft. I delved into the magnetic confinement of plasmas within ion thrusters, which was an unintended Star Trek overlap. I'm a huge Star Trek fan, and that ion drive actually powers the Star Trek Enterprise. But in my research at University of Southern California, I sought to understand the physics behind why the engine started to wear in a particular way to improve its lifetime. But at the same time, because I focused on understanding the fundamental physics, I also discovered a way to improve its performance as well as its life. So I took that knowledge, I was able to make design improvements to the engines that soon flew after on NASA's Dawn spacecraft, which traveled to the main asteroid belt. And 2 decades later, Now I'm working on hydrogen fuel cell powered electric propulsion systems for aircraft. So I still apply that knowledge from my PhD program in high voltage and high current, and I apply it to translate it into zero emission aviation applications. So the foundational knowledge that you obtain during your university degrees can and will be translated again and again and expanded upon throughout your career in ways and areas that you never thought were possible. So the second topic I want to talk about is humility, and this is my absolute favorite quote from Socrates, the ancient Greek philosopher. "The only thing we know is that we know nothing." That's a pretty heavy quote right there. And this is the definition of humility, and it comes from the desire and ability to be a lifelong learner, to keep digging deeper, to gain a better, bigger understanding of the natural world and of ourselves, to take on challenges that get you to question what you thought you knew as a fact was simply an assumption, and that you must always question, update, and further understand as you go through your career. When you finally realize, when you're working on a problem, that you don't really know anything, that's actually an epiphany, that you get to learn anew and transcend to new ways of thinking. Example for my career was after I finished my PhD, I was asked to lead the development of the largest supersonic parachute that had ever been flown for the next Mars rover mission at NASA's Jet Propulsion Laboratory. And at that point in my life, I hadn't actually touched a parachute, let alone flown one on another planet. But I wanted to work on the next Mars mission because it was an opportunity that could not be missed. And my management knew that I had this personality to take on tasks and learn from others. So off we went. I assembled a team. I had many experts to pull from, and I had a very experienced vendor who had built prior Mars mission parachutes before, all the smaller ones. So 6 months into the development, in our very first test of an engineering model parachute, the parachute exploded after it inflated, and it was hurtling, falling from the sky, made a crash landing on the ground. As it was falling from the sky, I realized this is a humbling experience. But we worked together as a team to create a new solution. We built a parachute, a better one, a stronger one. We conducted many more tests. Move forward a few more years. In 2012, we landed the Curiosity rover on Mars with the largest parachute that we'd ever built and deployed supersonically. And post-landing, we all received a photo that was actually snapped by the Mars orbiter spacecraft showing the parachute with the rover dangling beneath it, but this time at the correct speed. So the message is, if you are willing to learn from others and overcome failure, you can do whatever you put your mind to. This is such an important lesson for research technologists and for engineers across the board. So my next topic I want to talk about is purpose. Technology has the ability to solve so many global challenges, and I would argue right now, climate change is perhaps the greatest challenge and the greatest opportunity in human history. Albert Einstein said, "Only a life lived for others is worthwhile." Leonardo da Vinci said, "Make your work to be in keeping with your purpose." So in 2020, I decided it was time for me to make my work my purpose and to take the leap into entrepreneurialism. I wanted to focus the second half of my career on climate change mitigation. So I started my company, Hydroplane, with a specific goal to decarbonize aviation, and armed with my research training as a commercial pilot, and desire to solve big global challenges, I knew that I could bring a sustainable solution to bear. So I wrote a small business research proposal, won an Air Force research contract to design a hydrogen fuel cell power plant for an aircraft and electric vertical takeoff and landing vehicles, and off we went. And I felt that repurposing military funding for climate change mitigation was also a win-win, because it gives us energy resiliency as a nation and ultimately a more sustainable solution to electrification as compared to batteries. I wanted to take on this challenge because it was purposeful, and I had the skills to do it. 4 years later, we have a hydrogen fuel cell powered aircraft and have also demonstrated a full-scale helicopter rotor powered by a hydrogen fuel cell, and in total have won 5 government contracts. So armed with purpose and knowledge, I believe that anything is possible for each of you. Remember, I was a BU grad. So topic 4, resilience. Resilience is the ability to pick yourself up, to get back on the horse, to keep blazing that trail, regardless of technical setbacks, but more importantly, regardless of the unfairness of the world. Maya Angelou said, I can be changed by what happens to me, but I refuse to be reduced by it. That is an amazing quote that resonates with me, certainly. So, an example from my work. When I was in my mid-30s, I proposed and led a mission that was for an atomic physics facility aboard the International Space Station. It was an experiment that we were building. We, of course, had numerous technical setbacks during the course of the development. We had hardware failures during tests. We had to ask for more funding. That's never easy. But my greatest challenge was facing harassment as a woman from male customer representative. That was just prior to the Me Too movement, so I had little recourse other than to put up with it or move on. I chose to put up with it for as long as I could, but ultimately I had to exit the situation. It was the hardest thing I have ever had to do in my career, but I used it as an opportunity to blaze a new path. And what I did was I got recruited, and I became Senior Vice President of Systems Engineering at Virgin Hyperloop, where I led the development of a new form of green ground-based transportation. And in this role, born of having to leave a very difficult situation, I learned an entirely new set of soft skills in leading people and business strategy, as well as hard skills in the areas of magnetic levitation, electric propulsion, safety engineering for transport systems, and ground-based infrastructure. So from getting back on a new horse, I grew 100-fold as a leader, as an engineer, and on a personal level. Resilience is a key trait for a technologist. Overcoming extreme obstacles is the key to growth and impactful change, and you must embrace it during the course of your career. If you do, you will soar to new heights and recognize just how strong you can be, each one of you. So my last topic is compassion. One of the greatest gifts we have as human beings is the capacity for empathy, to sense what others are feeling, and to make choices in how we behave to help an individual, whether that is a human or any animal for that matter. And Amelia Earhart, the famous aviatrix, said, "A single act of kindness throws out roots in all directions, and the roots spring up and make new trees." So an example from my life, in this case public service, during COVID-19, I saw so much suffering in the news. I saw hospital workers putting themselves on the front lines, putting their lives at risk. And I was at home in my house, working remotely on my computer, ultimately not contributing to the global solution. As a result, I felt like I had to do something, so I decided to volunteer with the Red Cross. I volunteered regularly at blood banks and at a local food bank. And as a healthy person, I just felt obliged to help. And in an ironic twist of fate, as I was volunteering at a food bank one day, I ran into the Civil Air Patrol, which was an emergency service volunteer organization, which was part of the US Air Force. I joined the Civil Air Patrol soon thereafter, and it gave me exposure to the armed forces and their ways of operation. Fast forward 2 years, and my small business had 2 Air Force contracts to develop electric propulsion for aircraft, 2 Navy contracts to develop hydrogen-powered generators, and an Army contract to develop a hydrogen-powered helicopter. There's no direct link between my desire to help and winning military contracts, but in doing this, it gave me exposure to the armed forces, their concept of operation, and their unique needs, and ultimately helped me to write much better proposals. But most importantly, it allowed me to help my local community. So in closing, I want to close with my favorite poem by John Masefield. It's called Sea Fever. It's also the favorite poem of Captain Kirk. I find the analogy between sailing vessels and science fiction to be inspiring and introspective. It goes like this: I must go down to the seas again, to the lonely sea and the sky, and all I ask is a tall ship and a star to steer her by. And the wheels kick, and the wind's song, and the whale's sails shaking, and a gray mist on the sea's face, and the gray dawn breaking. Congratulations, class of 2025. May your career journey be filled with adventure, the occasional course correction based on lessons learned, and ultimately guided by compassion and purpose for the world around us. Thank you.